Hi, and welcome to your first set of flipped class notes for Honors Chemistry. During this video, you will need to pause the video so that you can write down the things that are on the slide. It might be useful to pause and take the notes, and then to just go through and watch the video once all your notes are taken so that you can see it without the interruptions. So, chemistry. It's the science that deals with the materials of the universe and the changes that those materials undergo. So we're going to be looking specifically at compounds, elements, how they react, how they form, how they come together, and what causes them to react. Things that are examples of chemistry: burning wood, okay? Looking at plants grow. And that can also be further taken into biology because there's a whole biological component to that. Iron rusts when exposed to certain elements. Bread bakes. There's tons of food chemistry and chemistry involved in baking and cooking. Human digestion. The way our food is broken down is a chemical process. And so all of these processes, which some you'll explore more in depth in biology, are all part of chemistry. So we need to review the scientific method, and I'm assuming that you've had experience with this before. But when we go through the scientific method, when we're looking at any sort of problem, we state what the problem is. We define what we're looking for. Then we're going to make observations, and so we're going to observe whatever the situation is at hand. We're going to form a hypothesis, and a hypothesis is just an educated guess. It's something where we're predicting what the outcome is going to be. We're going to perform an experiment, so we need to test our hypothesis. And so we're going to design an experiment. And during the course of that experiment, we're going to make observations. That will allow us to develop a law, which is a summary of the observed behavior. And then we can then further develop a theory, which is then the explanation of whatever that behavior is. And always, because it's science, we will continue to experiment. We may need to modify our laws or modify our theory as new things are discovered, but that's the ongoing process of science. And as I said, we can modify our theory as we need to. So some important terms. We've touched upon these when we've done our candle observations, but now it's time to get them formally in our notes. Matter. Anything that has mass and volume is considered matter. And so what we're going to deal with in this course is matter. Mass is the amount of matter in an object. So how much matter is in that object is related to what its mass is. Volume is the amount of space an object occupies. And then we had two other terms that we came up with our candle observations, and we need to formally get them in our notes. Qualitative observations. And as we learned in class, our qualitative observations are observations that don't require measurements. And so our examples were things like color, taste, smell, things that don't have a number associated with them, which is opposite of our quantitative observations, which are observations that do require measurements. So those are things like saying that something is 17 centimeters, or 5 pounds, or 35 inches wide. If I say that an object is tall, that's a qualitative observation. As soon as I add the number, the object is 35 feet tall, now it's a quantitative observation. So it's very easy to delineate between the two because that quantitative observation will always have a number attached to it. Now we need to look at the classification of matter. Matter, we know, has mass and it has volume, but we can divide it up into several subgroups. We can have pure substances, and pure substances we can write a chemical formula for. And so we'll get very specifically into writing all kinds of chemical formulas, but let's just use one that we're pretty familiar with, H2O. H2O is water, and I can write the chemical formula for water. This is different from a mixture. A mixture has a variable ratio. So an example of a mixture is something like salt water. I can write a formula for salt and I can write a formula for water, but I can have different concentrations of salt in my saltwater mixture. And so I could have, 1 cup of water with a half a cup of salt, or I can have 1 cup of water with a teaspoon of salt, just to give you, sort of a visual. So mixtures have a variable ratio, and I can't write a formula for that mixture, even though I may be able to write formulas for the components. Pure substances can then be further broken down into elements, which is what we're working on learning. So our elements that we have in water is we have hydrogen and we have oxygen. Those are my 2 elements that are part of water. Compound are 2 or more different atoms chemically bonded. And so my pure substance in this case that I picked was H2O. That's a compound. And so looking at this, pure substances are also elements. Okay, so we could have had hydrogen up here as an example of a pure substance. Mixtures, on the other hand, we have 2 types. We have homogeneous solutions and we have heterogeneous solutions. Homogeneous means that all parts look the same, whereas a heterogeneous solution has visible differences. And so some examples of homogeneous solutions that you want to put down. A homogeneous solution, salt water. Salt water looks the same. If I have a sample of salt water and I have a cup of it or I have a gallon of it, it's going to look the same. You don't see any visual parts. We use a lot of food analogies with homogeneous and heterogeneous solutions. Lemonade. If I pour 1 glass of lemonade, the first glass is going to look the same as the last glass. That's a homogeneous solution. If I think about things that are heterogeneous, I have different visible parts. So if I look at something like chocolate chip ice cream, okay, so that mixture, I can see the different chips in it. If I were to scoop, 1 scoop might have 10 chips, 1 scoop might have 15 chips. It's heterogeneous. Whereas, pure plain vanilla ice cream with no vanilla bean flux or anything, and that would be a homogeneous mixture. Okay, and another example of heterogeneous, if we want to go back to a solution, is you think of Italian salad dressing. It has the oil and the vinegar, and then you have to shake it in order to mix it together, but it sits and it separates, and so there's visible differences, and so that would be a heterogeneous solution. Energy, a little quick review of physics. All objects possess energy. There's 2 general forms of energy that objects have, and your physics teachers would like you to remember. Potential energy is the energy of an object due to its position, and kinetic energy, the energy possessed by an object due to its motion. And then the law of conservation of energy. Energy is neither created or destroyed. And this is just a quick little review from physics because we're going to be dealing with the transfer of energy in this course. Energy can be converted from one form to another, and we're going to look at a lot of those conversions, especially in the form of heat. We'll have a whole unit on heat energy. And then phases of matter. Solids have definite volumes and shapes. We can measure their volumes, we know their shapes. Liquids have a definite volume, but they take the shape of their container. So we pour water, we can measure what the volume of that water is, but the shape is going to be whatever shape container we put it in. And a gas, it doesn't have a definite volume and it doesn't have a definite shape. It's going to take the shape of its container, and it can be compressed or expanded to fill its container. And then physical and chemical properties and changes. And so this is your introduction before we get into a lab on this. But a physical property are characteristics that describe a substance. And a physical change is a change that does not affect the composition of the substance. So a physical property is describing how it looks. A physical change is something that doesn't affect the composition of the substance. My favorite analogy is if I have a piece of paper and I rip it in half, it's a physical change. I now have 2 pieces of paper, but it's still paper. I didn't make it into something new. It still stays as paper. If I take water and I heat it up and I boil it and I recollect the steam, I can recollect it. Any phase change is a physical change. If I have ice and it melts into water, and then I take that water and I put it back in the freezer and freeze it, it's still water. A chemical property are characteristics that refer to the ability to form new substances. So a chemical change is a change which produces new substances. Combustion, when we burn something, it's a chemical change. I can't recollect the smoke and steam and ash and put it back together into the wooden log that I had burned. We burned our candle. There was some physical changes with the wax melting, but ultimately we had a chemical change because that wax vapor burned away. I couldn't recollect the smoke and whatever and reform a candle from the things that were being emitted into the classroom. And so we will do a lab that will illustrate physical and chemical properties and changes, but those are your definitions so that you have them in your notes.